Okay, we're continuing with part 3, number 8, part D. The first thing I need you to do for me is take 6 out of here and change the function to make it a little bit easier. If we keep this 6, it's going to get a little bit more challenging. Let's just make it a little simpler. Now to find the period, all what I need you to do, take negative pi over 2 and make it less than x minus pi, less than positive pi over 2. I need you to solve for x, adding pi to all 3 sides, and this function is going to be pi over 2 less than x less than 3 pi over 2. The length of this period from here to here, it's going to be only 1 pi. Continuing with the graph, we're going to go from pi over 2 to 3 pi over 2 and mark these as asymptote. Now, since we are graphing a tangent function, I need you to repeat that for one more period. It will make sense here if we repeat it to the left. So if I go 1 pi to the left, then I find myself doing it at negative pi over 2, and that's my third asymptote. I'm graphing 2 periods. The midpoint of each period is going to be your x-intercept. This is going to be 0 and pi. Those are my x-intercept. Next, I need you to find the midpoint of each interval. This midpoint is negative pi over 4. This midpoint is pi over 4. This midpoint 3 pi over 4. And then we have 5 pi over 4. Out of those 4 midpoints, I need you to take one of them and let's go ahead and test it. I decided to test the point x equal 3 pi over 4. Let's just go ahead and plug it back into the original function, which is y equal negative 2 tangent of x minus pi. X is 3 pi over 4 minus pi. That will give us negative 2 tangent of negative pi over 4. As you can see, if you go to the unit circle, this will be negative 1, and the answer will be just simply positive 1. So the ordered pair will be 3 pi over 4, comma 1. Let's go back to our graph. 3 pi over 4, comma 1, it's going to be right over here. So the point will be right over here. This is 3 pi over 4, comma 1. We know we're going to cross at the x-intercept here, which makes 5 pi over 4 go down to negative 1. 5 pi over 4, negative 1 is another point on the graph. Connecting those 3, it's going to make the graph go from asymptote to asymptote. Now we're going to repeat this graph over here, which makes negative pi over 4 symmetrical goes to 1, and positive pi over 4 is going to go to negative 1. Connecting those 3 locations, starting near an asymptote, crossing here at the x-intercept, and then ending near the asymptote, and that's my graph. The most important points to remember are your asymptotes. You have 3 of them. You have 2 x-intercepts at 0 and at pi, and you have 4 key points to keep track of. 1, 2, this is the third, and this is the final 4. Part E, graphing a cotangent function. We're going to find the angle between 0 and pi. I need you to solve for x, adding pi over 6 to all 3 sides, which gives us pi over 6 less than x less than 7 pi over 6. That tells us that the length of the period from here to here is only 1 pi. We're going to graph 2 of those periods. Let's go down to the graph and start graphing. So the first period is going to be from pi over 6 to 7 pi over 6. That will give us 1 period. Those are your asymptotes. And we're going to repeat that one more time because it's a cotangent function. We're going to graph 2 periods. So if I go one more period to the left, I'm going to end up at negative 5 pi over 6. The first thing we're going to do, we locate the midpoints. The midpoint of this interval right here is 2 pi over 3. That's going to be an x-intercept. And the midpoint of this interval right here is negative pi over 3. And that will be my x-intercept as well. Now what I want you to do is locate the midpoints of each interval. This one here will be negative 7 pi over 12. This interval is the midpoint at negative pi over 12. The interval here has a midpoint at 5 pi over 12. And the final interval here has a midpoint at 11 pi over 12. Out of those four midpoints, I need you to take one of them and test it. So let's go ahead and pick one of them and see which one we're going to test. I prefer to test the point x equal to 5 pi over 12. Let's go back and plug it into the initial function, which will be the cotangent x minus pi over 6, but we chose to do 5 pi over 12 minus pi over 6. Do common denominator. This will give you the cotangent of 3 pi over 12, 3 pi over 12, or simply pi over 4. Cotangent of pi over 4 is simply equal to 1. So the ordered pair will be this. Let's go back to our graph. 5 pi over 12 gives us 1. So if this is 1, this is the point you're going to cross at. This is the x-intercept, and at 11 pi over 12 obviously is going to go down to negative 1 due to the symmetry. We start near the asymptote, we cross here, and finish there. The same thing, we're going to repeat this pattern here. At this point is going to be negative 7 pi over 12, 1. This is the x-intercept, and this point will be negative pi over 12, negative 1, and so the point will be about right here. We repeat the graph. So what is expected of you? Those 4 points, this one, that's the second one, this is 5 pi over 12, comma 1, that's the third, and the final point will be 11 pi over 12, comma negative 1. That's the final point. And keep in mind your asymptote and your x-intercept. The x-intercept do not have to be in ordered pair. Part F. Graphing a secant. We're going to pretend, just simply pretend we're graphing the function y equal cosine x plus pi. So that means we take the angle x plus pi and we squeeze it between 0 and 2 pi. And we solve for x. To solve for x, this is going to be negative pi less than or equal to x less than or equal to pi. The length of this period from here to here is 2 pi. Let's just go ahead and graph it. To graph this function right here, I am going to label the axis from negative pi to positive pi. Since we are graphing a cosine function, I need 5 key points. That will be 0. This will be negative pi over 2. This will be your positive pi over 2. Now to graph a cosine function, we will be at negative pi going up to the amplitude, which is a 1. And then at negative pi over 2 is going to be an x-intercept. At 0 is going to go down to negative 1. At pi over 2 it's going to be an intercept. At pi is going to go back to positive 1. Now, as you can see, we just made a pretend here to graph the cosine. But in order for us to go to the secant, I need you to find your asymptote, which are your x-intercept. This is an asymptote, this is an asymptote. And to finish up with the cosecant function, we go to this point right here, which is 0, negative 1. It becomes a vertex of a parabola. Make sure you end near the asymptote. This is one of the key points that I need from you. This point right here, it's going to be half of the parabola because we don't want it to go to the next period. And so that will be negative pi 1. And the last point right here will be pi positive 1. Those are 3 key points. Keep in mind you have to give the asymptotes at positive pi over 2 and negative pi over 2. Part G. Graphing a cosecant function. Pretend it's going to be a sine function of 3x. Go ahead and put 3x between 0 and 2 pi, and this time you are not allowed to put an equal on inequality. So if we divide by 3, this is going to give us 0 less than x less than 2 pi over 3. The length of this period from here to here is a very short period. It's 2 pi over 3. Let's go ahead and graph it. Graphing a simple function a sine function from 0 to 2 pi over 3, we need 5 key points. So obviously the middle is going to be pi over 3. The midpoint right here is pi over 6. The midpoint right here is pi over 2. We know we have an amplitude of 2. That means we're going to go up to 2 and negative 2. First, I'm going to graph the sine, then I'm going to reflect it over the x-axis. So at 0, it goes to 0. Pi over 6 is going to go down to negative 2. Sorry, this is with the reflection. And positive 2 is going to go here, and this is going to go there. Now, this is the sine reflected over the x-axis. What I wanted to do next, I wanted to go ahead and put the asymptote to finish up with the cosecant. Asymptote here, an asymptote there, and an asymptote here. So as a result, we have 3 asymptotes at 0, at pi over 3, and at 2 pi over 3. To finish up with the function, we're going to graph a parabola here and a parabola there. Now, we need to finish near the asymptote, but you have to give me those 2 points. Pi over 6, negative 2 is a key point, and pi over 2, comma 2 is another key point. Done. Part H, graphing a secant function. We're just going to pretend it's going to be a cosine function, and the cosine is going to be x minus 3 pi over 4. Now keep in mind, this is going to be reflected over the x-axis. This is an amplitude of 4. And for the period, we're going to put it between 0, and we can put an equal here on the inequality, 3 pi over 4. Add 3 pi over 4 to all 3 sides in order to solve for x, and we will get 3 pi over 4 less than or equal to x, less than or equal to 11 pi over 4. Let's just go ahead and graph it. Continuing with the graph, we're going to go from 3 pi over 4 to 11 pi over 4. Since we are graphing a cosine function, I need 5 key points. The midpoint right here will be 7 pi over 4. The midpoint right here is 5 pi over 4. The midpoint right here is 9 pi over 4. Now keep in mind, we're graphing first the cosine function. To graph the cosine function, we have an amplitude of 4, and we have it down to negative 4. And we want the one that's reflected over the x-axis. If we reflect it over the x-axis, at 3 pi over 4 goes to negative 1, 5 pi over 4 is going to go to 0, at 7 pi over 4 is going to go to 4, 9 pi over 4 is going to get to 0, and 11 pi over 4 is going to come back to negative 4. Now we're going to continue with the secant function. We're going to draw the asymptote first. This is 1. And this is the other one. Now we have to continue with the secant function. The first part is going to be over here. So the key point right here will be 3 pi over 4, negative 4. That's a key point. This is an asymptote here. At this point will be 7 pi over 4, 4. That's another key point. This one here is an asymptote. And the last point right here will be 11 pi over 4, comma, negative 4. Ta-da!